So good morning, good evening, good afternoon, wherever you are. My name is Vishnu Dutt, and today we are starting our exciting journey into the world of IPv6. Believe me, this protocol is not new at all, right? It was developed around 1990s to 2000, but nowadays we are seeing a rapid demand of IPv6. Why it is the case, we are going to discuss it. So agenda is going to be very simple. First thing first, we will be talking about why behind IPv6, and you will be amazed to see that internet now is going in what phase, right? We are going to talk about some interesting facts about IPv6, and your mind will be blown after listening to them. Then we need to understand why exactly there are no broadcasts in IPv6. Because if you are aware of IPv4, if I say, guys, IP, right? If I say IP, the meaning is IPv4, right? If I say IPv6, of course, meaning is IPv6. So I get sometimes confused. But if I am saying IP, the meaning is IPv4, okay? So if you are aware in IP or in IPv4 that without broadcast, there are lots of functionalities which are not going to work, right? For example, if you see the combination between IP and ARP messages are going to be broadcast. Otherwise, we are not able to find the MAC address of other systems in the same LAN, right? We will be talking about it, but believe me, there are no broadcasts in IPv6. And it is going to be an interesting thing. If you want to understand why there are no broadcasts and still IPv6 works, right? We need to understand a little bit about addressing of IPv6. Once we have these three topics in our pocket, we can talk about the plug and play nature of IPv6, which is really, really important in today's world. We just need to connect our device into the network and it should work. This is the meaning of plug and play. And IPv6 is truly a protocol which is plug and play. Then there is a question, means there is a question from everybody. We have IPv4, we have IPv6. Where exactly this IPv4 is? Sorry, IPv5 is. Have we developed this protocol ever or not? We will be talking about it. There are going to be some interesting fact about IPv6. Believe me, India's adoption rate of IPv6 is phenomenal, right? And we had to do it. Why? We will be talking about it. And at last, many people say that, Vishnu, you are teaching us old technologies always. IPv6 is old, but believe me, it is getting adopted by everybody, every nation, right? In the world of artificial intelligence. Why so? We will be talking about a connection between AI and IPv6. Believe me, AI, if you see AI, we are building highway for AI using IPv6. And if you know this technology, if you know this, uh, if you know IPv6, you are going to be very much relevant in upcoming 10 to 12 years or 10 to 20 years. So have a look at that. Again, this is the simple agenda. I would like to start with a promise that if you give me your next 1 hour, these concepts are going to be with you forever because we will be learning them from absolutely from scratch. Having said that, let's talk about why behind IPv6 and a little bit history of IPv6. Do not worry, I am not presenting history in a boring way, right? So what is happening? What was happening around 1990s? Or basically, let's go a little bit 15 years back than that. In 1975, there was one incredible thing happened, right? And that thing was birth of IPv4. And people were so amazed to see that packets were moving from one computer to another computer. And it was really, really astonishing to see. Then what happened? Nobody assumed that the project which was started for as a defense project, means to connect some of the defense institutes with big universities for the research purpose, it got so popular that the computers which were using IPv4, right, they were rapidly increasing. Around 1990s, people thinking about the problem that currently in IPv4 we have approximately 4.3 billion IP address. What is the meaning of billion? See, we are Indians mostly. If I see the people are from India, right, and we do our counting in crores, lakhs, right? So to give you a rough idea, the meaning of 1 billion is actually equal to 100 crores. So how many IP addresses we have if we consider that IP address is a 32-bit long, right? It means that 2 to the power 32. If you do that, you will be coming across 430 crores IP addresses. Believe me, when somebody started this project IPv4, when they developed it, nobody thought at that moment that 430 billion IP address will be short or will be depleted in coming time, because nobody thought that internet is going to burst this much, right? So around 1990s, people were thinking that these much addresses, 4.3 billion addresses, are not going to be enough, right? Because you all know that IP addresses are divided into different classes: class A, class B, class C, right? And in around 1990s, class A and class B addresses were almost finished. I'm talking about in 1990s, right? So there was one guy, Mr. Or Dr. Steve Deering, right? He was one of the major architect in building IPv6. So this guy was saying that in around 2010, 2015, believe me, IPv4 addresses are going to be finished. We need to do something now. And then he was among some of the architects who started building IPv6, right? And he was quite right. I will tell you in upcoming slides that in 2011, all IPv6 IP addresses were finished. Finished means depleted. What is a meaning? I will be talking. It doesn't mean that we can't have new IP addresses, because we are not getting them from the highest authority. We are going to get them from our service provider, which is already having some IP addresses in reserve. But this problem is going to happen soon. And this guy say, even we are using network address translation. So by the way, network address translation is a technique through which, through one public IP address, only one public IP address, thousands of devices can access the public internet. And these thousands of devices can be on a private side of addressing. If you do not know about public side of addressing, private side of addressing, believe me, I have created so many things on my YouTube, and things are freely available on my website. Please have a look at it, right? So network address translation was something which was rapidly used at that moment, right? And why we were using to conserve IP addresses. But believe me, Dr. Steve Deering said, this is inevitable that our addresses, IP addresses, are going to deplete in coming years. We have to work something. And that is why this guy worked on the future growth of internet, right? And this guy was one of the amazing architect who built IPv6, right? So I think you got the idea from where IPv6 is coming into picture. Now, let's move to the next board, where we are going to talk about how these IPv6 addresses or IP addresses are assigned, so that you can understand why these addresses are depleting so fast. So there is a highest authority, right? The name is IANA. The meaning of IANA is Internet Assigned Number Authority. So by the way, guys, if you are not able to see this, whatever I have written here in the red color, believe me, these are my notes. These are not for you, so that I do not forget whatever I have prepared for this webinar. So if you are not able to see whatever is written in these red here, do not worry. These are not for you, right? So what is happening here? So there is one highest authority who distributes these IP addresses. The name is Internet Assigned Number Authority, which you can see right here, right? What this authority, this is in total control of IP addresses, right? And then this authority assigned or provide the IP address to regional registries. What is the meaning of regional registries or regional internet registries? There are 5 different regional registries or regional internet registries whose responsibility is to give IP addresses to different part of the world. For example, APINIC is the regional internet registry which is responsible to provide IP address to Asia Pacific region. And of course, India is inside this Asia Pacific region, right? So there are 5 different registries, like what we have ethnic, we have Africa region, we have Northern America region, and so on. So what IANA does, it gives the big blocks of IP addresses to this regional internet registries, right? If I say a big block, suppose we have an IP address is 7.0.0.0/8. If I write /8, the meaning is the starting 8 bits are for network. The remaining the remaining 24 bits are for host number, right? So it's a huge address space. How many addresses we can have it from here? If we can have 2 to the power 24 addresses. If you do not know the math, that is perfectly fine. But I am just saying whatever the number of hosts you have, whatever the bits in you have in number of hosts, you just make it to the power of 2, and you will be getting the number of IP addresses you can get from that subnet. So these subnets are really big, /8, and INA is providing these subnets or other subnets to regional internet registries. As simple as that, right? And eventually, these regional internet registries will be providing the IP addresses to internet service providers, big data centers, big enterprises also. If we talk about India, we have Geo, Reliance Geo, right? And this is the responsibility of AppNIC to provide IP addresses to Reliance Geo, right? We have many data centers here in India, right? And it is a responsibility of regional internet registries to provide IP addresses to data centers, to big enterprises. And eventually, once once we have the IP addresses with ISPs, DCs, and big enterprises, we will be having IP addresses for our customers. What is the meaning of customers? The customers is us. For example, if I go to internet, if I go to Airtel and ask him to give me an IP address, to give me an internet connection, what Airtel is going to do? Airtel will be providing you a public IP address, and you will be configuring that IP address on your router, this Wi-Fi router. And then you are creating your own LAN, means 192.168. And of course, NAT is going to be there. NAT is still there, right? But with this IP address, with this single IP address, almost everybody inside your home is going to get access to internet. There is no doubt about it, right? So Geo, what is Geo going to do? It will be providing us a router, and of course, it is providing us that public IP address. Although I'm not telling you everything, because there is a few things called carrier grade NAT, which sometimes these ISPs use to save public addresses. But let's not go into that. Just try to understand the structure, how these IP addresses are going to be distributed. And similarly, IPv6 addresses are going to be distributed, right? But we are talking about IP first. So IANA, the topmost authorities, give IP addresses to regional internet registries. Then they give IP addresses to ISPs, DCs, and big enterprises and customers. Why were these IP addresses were finishing, right, around 1990s? So there were no efficient mechanism which IENA was using to provide addresses to regional internet registry. Believe me, at that point of time, around 1980s, 1990s, nobody thought that we would be there won't be any IP address remains when we reach to 2025, 2020. These authorities were distributing these IP addresses like anything, right? For example, the big enterprises got /8 network, which nobody wants, right? And there are many big enterprises which got the / addresses at that point of time. And that is why these addresses are not no more with us, as simple as that, right? So no efficient mechanism at that point of time. But if you see, I would like to showcase you around in 2011, right? Almost all IP addresses which could be assigned by INA to regional internet registries were depleted. What is the meaning? The meaning is in 2011, there were only 5/8 addresses remained with INA, only 5. And what INA did, it distributed all these 5/8 addresses or subnets to 5 regional internet registry. And that is it. It means that IANA does not have anything now. It doesn't have anything now to distribute to regional internet registries. But you can ask me a question, Mr. Vishnu. If that is the case, how come if I go to my service provider, right, I still can have an IP address? Believe me, nowadays, I'm not saying that these regional internet registries not have the IP address. Maybe those have, and those can assign to your ISPs, and ISPs can assign to them. But that day is not far when these addresses are going to be used, because if you consider only India's population, it is 1.4 billions, right? Not dollars. It is only 1.4 billion. It means that 140 crores. If you consider world population, it is 8 billion. And we have only 4.3 billion IP addresses. And now I'm talking about human. One human can have multiple devices, mobile phone, iPad, laptop. And now if you consider, we have Internet of Things, our refrigerator, our TV, our fridge, right? Now that is also on internet. How we are going to meet all these demands? And now autonomous cars are also coming. And when these cars, maybe C1, car 1 and car 2 on road, they want to talk to each other directly, right? These also need an IP address. So we are not going to cater the need of today's world, right? With this 4.3 billion IPv4 addresses, we need something different, right? So overall, if I talk about world population, which is 8 billion, and try to consider this, right? Out of 8 billion, 1.4 billion live in India. Interesting fact. Almost 1 out of 5 people in this world is an Indian. So interesting statistics. The overall thing is that we need something which has more and more number of addresses, because otherwise we won't be able to cut. And I am telling you, in 2011, there is an article, right? If you want to read, IPv4 address is depleted. Just look at the internet, right? And it will showcase you last 5/8 addresses were distributed by INA to RIR. INA doesn't have anything with respect to IP addresses. As simple as that, right? So what we are discussing right now, we are discussing why behind IPv6. I think you get the idea that there is a need. And by the way, one more interesting statistics. If you talk about 2011, there were only 0.6% of internet traffic was on IP6. Only 0.6%. Everybody was using IPv4. Nothing with respect to IPv6. But if we talk about 2025, you will be amazed. I will be talking about what is this percentage number at 2025. Your mind will be blown away when you see this. And that is why we are building this course on IPv6, where we will be talking everything about IPv6, not everything, basically to begin with, to understand it, to implement it in 8 classes. We'll be talking about it for sure. Now, is there any other reason why behind IPv6? So what we got, see, in 1990, as I was talking about, that guy, right, who was talking about IPv6, he developed, the people were developing IPv6. And now in 1975, IP was developed. In 1990, IPv6 work started. So how many years we have in between? 15 years. It means that the engineers who were building IPv6, they have 15 years of experience. So do not worry about it, that you must be thinking that now, do I need to learn? Do I need to learn IPv6? Do not worry, your 15 years of learning or whatever you have learned in IP, it is going to be used. So this guy, or all these guys who have developed IPv6, what is their strategy to develop IPv6? They said, whatever is going good with IPv4, we are going to retain it while designing IPv6. So this is the good news for you. If you know IPv4, most of the things are going to be as it is in IPv6, right? Interesting. But they say that now we are getting a chance of redesigning IP, right? The next generation of IP. We should include some efficient mechanism in it, right? And they want to make it more efficient as compared to IPv4. And that is what they have done, right? And of course, they need to cater the scalability requirement, because they know that in upcoming world, it is not about billions, right? It is going to be hundred of billions, of 200 or 1,000 of billions IP addresses are going to be needed, right? It means that they need to consider scalability also. So 3 things. They took everything which is going good with respect to IPv4. They have included that into IPv6, right? They made it efficient. They made it scalable, as simple as that. And one of the efficient mechanisms of IPv6 is its plug and play nature. You do not need DHCP to assign an IP address to these devices. For example, what we have a switch here, we have a router here, and we have few hosts or PC. We have PC number 1, PC number 2, and we have PC number 2, 3, right? What you need to do, if this is a IPv6 network, believe me, you just need to insert this Ethernet cable into this laptop. And what it is going to do, it is going to have its own IPv6 address within no time, right? If you insert PC2, it is going to have its own IPv6 address in no time, right? And interestingly, you do not need DHCP for that. If you are not aware what DHCP means, when you go to your home or office, when you open your laptop, first thing first happens is that this laptop needs an IP address. So there is somewhere a DHCP server, right, which is Dynamic Host Configuration Protocol server. So your laptop, see, if you do not have IP address, this is how much important IP address is. If you do not have IP address, you cannot connect to internet. As simple as that, because you do not have any address. Where these packets are going to means if somebody wants to send a packet to you, if you do not have an address, definitely they are not going to reach you. So if you talk about this laptop, when you go to your office or maybe home, when you switch it on or when you open the lid, what is going to happen? This laptop is asking its IP address from the DHCP server. If this DHCP server is not there, believe me, you are not going to get this IP address. And if you are not going to get this IP address, it's a problem. You cannot connect to internet, right? So what are the various mechanisms in IPv4? You can assign this address manually. You can assign this address using Dynamic Host Configuration Protocol server, which is the DHCP server. You all know about it, right? But if we talk about what happens in IPv6, it is plug and play. The meaning of plug and play is very simple meaning, right? You can get the IP address on its own. How IPv6 address will be calculated, or how this PC2 is going to get this IPv6 address, it is an amazing process and very, very simple process, which we are going to discuss in the live classes of our classes, right? Okay. So automatic address assignment is there. We call, I think you have heard about this, SLAAC. The meaning is a stateless address auto configuration. You do not need any stateful device, right? You just plug your laptop, it is going to get the IPv6 address and everything is going to start working. This guy can connect to internet without DHCP by configuring its own IP address. I understand that there is some question from somebody. Do not worry about it. We will be taking it, right? Now, so what we have discussed till now, why behind IPv6? IP addresses are getting over. It means not getting over. Those are over now, right? But yeah, one more thing. If you see that today in today's world, we can also apply for a /24 subnet, definitely, because it might be the case that the regional internet registry or your service provider might have some /24. But nowadays, IP addresses are using as a thing in market, which can be, or you can say commodity, which you can sell and buy, right? So you can buy the IP addresses in the gray market, or in this regional internet registry, there are brokers who can give you IP address if you provide them money, right? Very, very interesting things are happening. So last thing, in IPv6, basically, we do not need NAT, because why we are using NAT at the first place, right? So first thing first, suppose we have these uh, uh, laptops which are into one network, IP network 192.168, maybe 1.0/24. We can assign them the IP address from this range. You all know about this address, that this subnet contains 256 hosts, and basically the usable hosts are two less than that. Why? I think you understand. If you're not, that's fine. So there are around 254 configurable IP addresses in this range. The router can take the first IP address and it is going to become the default gateway. You all know about it. Now the problem is with this 192 series, these addresses are known as private addresses, although there are three addresses from three different classes. Three subnet from three different classes are there: class A, class B, and class C, right? And every class has this private range. You cannot connect to internet using this private range, and that is why your service provider is going to give you the public address. Maybe the public address here you have configured is 7.7.7.10, suppose, right? If that is the case, what should be the solution? The solution is, whatever the traffic is coming, what if I change the source address of this traffic to this interface IP address? And that is what NAT does. NAT will be taking the IP addresses and converting them into the single IP address. How this communication happens? Port numbers are included, also included. This thing is known as NAT overload. I think you all know about it. But the important piece is, if you have here 254 devices, they can talk to internet using one single IP address. So NAT is the number one thing which has delayed the adoption of IPv6, because people were using it heavily. And why we were doing NAT? Because we are short of IP addresses or IPv4 addresses, right? But in IPv6, believe me, there is no problem with respect to that. Even one single subnet of IPv6 can cover entire IPv4 range. Very, very interesting. There are many subnets. There are going to be many subnets in IPv6, and one single subnet can contain the entire IPv4 range, right? I think somebody did research on this, that how much bigger this number is, addresses number is in IPv6, that if we have our earth and we cover this earth with the small grains or uh, small pieces of little stones, you can say, right? Entire earth, every little piece or every little grain will be going to have 100 or 1,000 of addresses. This is the scale. Do we need NAT now? No, right? And believe me, this NAT is a problem for many things. There is a list of applications, protocol, which do not simply work if NAT comes into picture. And because of this NAT, the developers of this application need to spend time in resolving issues, whatever is happening with respect to this NAT. Why? Because suppose if I have this computer number A, computer number B, this is behind NAT. So of course, this is also behind NAT. So I do not know what is the real IP address of B or the public IP address of B. B doesn't know the public IP address of A, right? It is just the case that this guy can initiate the communication to outside, and then basically communication can come inside, right? But nobody can initiate the communication towards this device A. Why? I will be talking about it, right? It means that if your device is behind NAT and if they want to communicate to each other, it's a really big problem, right? Or somebody wants to initiate a communication directly to A, it's a problem. And then you must be thinking, Mr. Vishnu, you are not correct here. We are using WhatsApp, right? Means I have a mobile phone here, or maybe a laptop here. I'm using WhatsApp here. And my friend who is sitting in Delhi or maybe in Bangalore, who is also using the WhatsApp, right? We are behind a NAT device, but we can still talk. Believe me, what exactly happens? So when you write a message, suppose this is Anjali's computer and this is Rahul's computer, right? If you have attended my course, believe me, I always take example from the daily life, and our daily life characters are Anjali and Rahul. नाम तो आप लोगों ने सुना ही होगा, right? So what is happening here right now? If Anjali wants to send this message over WhatsApp, maybe she's just writing, "Hi Rahul." How it is going to reach here? Can it reach here directly? No, absolutely not. Believe me. Because Anjali do not know the direct IP address of Rahul, or maybe the IP address which is configured here at the NAT device. She doesn't know about it, right? If that is the case, how the things happen. So what this WhatsApp has done, WhatsApp has a server everywhere. Whenever you write "Hi Rahul," or whenever Anjali write "Hi Rahul," this device can definitely talk to internet, and these servers are internet for sure, right? So what is going to happen? This message "Hi Rahul" will be stored in this server, right? Here is "Hi Rahul," and it is written that it is sent from Anjali towards Mr. Rahul. And server is going to have all the profiles of all the guys who are on WhatsApp. So when Rahul comes online, that is why if you are not online, of course, you won't be getting this message. But as soon as you connect your laptop, your mobile phone to data, what is going to happen? Your laptop is going to connect to the server, and it is asking, is there any message for me? And if that is the case, this message will be delivered here. This is how exactly thing works. It is not a direct to direct communication. It is not a direct communication between Anjali and Rahul. There is some middleman is there. And the application who can talk directly to each other, they are known as peer-to-peer application, right? So it means that NAT is actually hindrance in developing peer-to-peer, or NAT is actually problem for developers to generate or to build this peer-to-peer application. That is why there is not much peer-to-peer application. I'm not saying that there is no way to find out the NAT address. There are multiple ways. If you have heard about Stun server, it is helping us. But try to understand, to just know the IP address of other party, we are doing so much of thing in IPv4. It is not required, right, in IPv6, because we do not have NAT there. We do not need to use NAT there. We do not need to conserve IP address in IPv6, right? Means we can conserve it for sure, but we should not use NAT there. If I give you another example, in case of peer-to-peer, just try to understand, guys. In upcoming worlds, cars, right? These cars or trucks are going to be what? These will be running in autonomous mode, no driver, nothing. It means that they need to communicate to each other on really fast basis, right? No delay should be there. What do you want? You want these trucks to communicate with each other directly, means on peer-to-peer basis. Do we need any middlemen here? We should not, otherwise the delay is going to be there, right? So, enjoying learning? If you have reached till this point of the video, I think you are enjoying learning, and I just do not want to waste your time. I would like to say that if you want to see this complete course, this course is available on my website, which is www.bridgewhy.com. Please have a look at it. And along with this course, there are so many other courses available. If you want to start your networking journey from the beginning, from the scratch, or if you are a seasoned networking engineer, please have a look at this website. So you can see here is my website. The link of this website is also available on the description area just below this video. Thank you so much and enjoy learning. And in this world of autonomous driving, AI world, we need fast communication. Peer-to-peer applications are going to be there more. And if that is the case, IPv4 is not able to cater those requests for futures. And that is why we need to change from IP to IPv6. I think enough why behind IPv6. Now let's come and understand a little bit about one of the most interesting thing. There are no broadcasts in IPv6, right? But to understand why there are no broadcasts in IPv6, we need to understand a little bit about IPv6 addressing. So if you do not know, and most of the guys I have seen people, when they see this address, they think now is the time. Let's not learn IPv6. We do not understand this scary looking IPv6 addresses. Believe me, one of the most simple thing, right? So what is going on here? If I talk about first thing first, instead of 32-bit, which we used in IPv4, because we need a scalable protocol, right? And suppose if you are a developer, if you want to understand any new technology, anything, just try to think from the mind of the developer of that protocol, right? So I think you understand there were problems, right? And previously, the IP address was only 32-bit. Now, if you are redesigning this protocol, considering the future needs also, definitely you would not choose 32 bits again for designing the addressing, right? And this time, these guys decided on 128 bits. Interesting, right? But now, how you are going to write these 128 bits? So they have divided it into 8 pieces. And these 8 pieces are separated by columns, right? And inside one piece, they are going to write 16 bits. It means that if you do 16 into 8, the mathematics, it is going to be 128, right? And that is what I am showcasing you. This is my first of those 8 pieces. This is the second of those 8 pieces, third, fourth, fifth, sixth, seventh, eighth. And now, you must be thinking, Mr. Vishnu, is this 00D1 represent 16 bits? I'm going to say yes, right? Because this number is written into hexadecimal form. In hexadecimal, how many characters are there? 16 characters are there. From where to where? From 0 to 9. These are what? 10. Then we have A, B, C, D, E, and F. If you count them, 6 more, and that is how basically we have 16 characters. If we talk about decimal number system, it is only having 10 from 0 to 9. If we talk about binary, it is going to have only 2, 0, 1. Right? And to represent one hexadecimal character, how many bits are going to be needed? Only 4, because 2 to the power 4 is equal to 16. How we are going to write 16? We are going to write 16 like 1, 1, 1, 1, as simple as that. How I'm going to write 10? 1, 0, 1, 0. Do not worry about it if you do not know these things. Just open a calculator and you can do it. But you should understand the mathematics behind it. If we know how to use the calculator, it doesn't mean that we should not know how to add or subtract two numbers. Easy, right? 120 bits are aligned in this. But now the problem is, see, we write things, we do things, and then we observe the problem. And when we try to resolve those problems, if you see this number, people are going to say, this is huge. How I'm going to type? I have a habit of typing 192.168.12.1, right? Or maybe 12.3. do copy paste, right? Otherwise, what you can do is let's work on some rules so that we can reduce, right, the writing work. So the rule is simple. There are only two rules, believe me, guys, right? And there are some more which we are going to talk about in the detailed lecture, detailed 809 lectures. But to begin with, IPv6, it is as much as simple that just look into a particular octet, or basically this this number means this piece. We have 8 pieces. You know about them. Just look in every piece that if there are leading zeros, we can avoid it. For example, if I want to write, guys, 0, if I want to write 10, or maybe the number 12, I can definitely write it. I can write it 012. It is again the number 12. I can write 0012. It is again the number 12, right? It means that I can remove this leading zero into a particular piece, right? But only the leading zero. It is not the case if you have written 203, this is 203, you can remove the zero. No. Only the leading zero. So what we are going to do, we are going to write this address again in the black color, 2003. There is no scope of reducing it for sure. CBD8, no scope of reducing it. But if you write 0003, these are the leading zero, just remove them. We can write only 3. 00BC, remove 00. You can write BC. We have 4 zeros here. Instead of writing 4 zeros, just write single 0, then 0. Of course, we can remove this 0 from here. We can little bit shorter IPv6 address. So we can remove all leading zeros. As simple as that, right? But now if we talk about, can we reduce it more? And definitely there is another rule for that. So if you have lots and lots of zeros which are coming to you consecutively, right? So basically, if you write here 0, this is not 10, this is 0000 because you have to write 16 bits, right? We are just showcasing you how to shorten the IP address. So this 0 is representing 16-bit, for example, right? 0000. But now if you want to shorten more, if you see consecutive zeros, just you can replace them with 2 colons, as simple as that. So instead of writing these 2 zeros, I can write double colon here. Interesting, man, right? But this rule can be used only once in an IPv6 address. And you need to think about it. Why can we use this rule only once, this rule? Because the leading zeros rule can be applied to any number of pieces, right? Whatever we have these 8 pieces. But this double colon rule can be applied to only and only once for an IPv6 address, right? Why? See, the whole sole purpose is, can you come from this address? If providing you this address, can you make this address? Of course, definitely, right? Because wherever you see a single 3, you can write 0003 in split. Wherever you see BC, you can write 00BC, right? But what is the meaning of this double column? The meaning of this double column is just put zeros. Whatever the number of zeros are remaining less from 128-bit, just put those many zeros, and as simple as that. So with this number, which number? With this number, you can easily create this number. There is no problem. And this is what we want, right? We should not want to lose any information. But now consider this thing, right? And if we would like to convert it into a shorter form, of course, 2003 should be there, then colon. We have these many zeros, right? Instead of these many zeros, we can write double colon, right? And then start with 00BC, which we can write BC only. Then A, B, C, D. Then instead of these all zeros, can I write again column? No, then it's going to be problem. Because these column is used means we are going to write everything about the IPv6 address, and whatever the number of bits are remaining, we will be replacing this column with the zeros. That's it, because two column represent zeros, and it cannot be done with 2 times, right? Then what is going to be there? 0000. We can write a 0, and then 38C colon D1. These are the simple 2 rules, guys. That is it, right? So don't worry, I will be taking questions. Just let me complete this. Although in live classes, we stop in the middle, right? But it is going to break the flow. I would like to tell you one interesting thing. Why did I tell you about these IPv6 addresses and how to shorten them? The reason is I would like to show one interesting thing to you, right? That why there are no broadcast in IPv6, but still everything works fine and it's a more efficient way, right? So what happens generally in the IPv4 address, if I talk about, suppose this is my subnet, right? And this subnet, just pay more attention, right? If you want a coffee, please take a coffee, right? Because next 10 minutes are going to be really crucial because I would like to explain you one of the most important concept in IPv6, which people have hard time to understand. What is happening here? Suppose I am taking an example of IPv4. What we are trying to understand, we are trying to understand why there is no broadcast in IPv6, right? But before that, let's try to understand what broadcast is in IPv4. Suppose this network is 192.168.1.0/24. I have taken the IP address 192.168.1.10. For this host, maybe host A, and for host B, the IP address is 192.168.1.20/24. What is going to happen if this host A wants to communicate to B? You all know. If you do not know, just have a look at my videos on address resolution protocol, how to computers talk in the same LAN, right? Or different LAN. It is going to be interesting. So what happens? Definitely, I am going to create a packet for that. The packet source is going to be my source address, means 1.10. I'm just writing the last 2 octets of IP address, and the packet destination is going to be 1.20. This is my source, this is my destination. But if I want to put this packet, IP packet on this Ethernet interface, what I need to do, I need to have source MAC and destination MAC. And that is where the problem is. I have the source MAC. Suppose my MAC is AAA. I can write it here, A:A:A. The destination MAC, which is BBB, which I do not know. If that is the case, what I do, I broadcast, right? I actually broadcast so that this message should be reached to everybody. And whoever has this address 1.20 can tell me about his MAC address, right? So what I do, I will create an ARP message. This ARP message will be going to all F. And in Ethernet, I have programmed this switch that if you have a packet for all F, it should be going to everybody here, here, and here. Of course, when they see the internal ARP message, what is the ARP message inside? ARP is asking, what is the IP address corresponding to 1.20? Of course, this guy, which is computer C, is not 1.20. Computer D, which is not 1.20, who is going to reply? Computer B is going to reply because this is 1.20 with its own MAC address, PPB. I think you all aware of that. The whole sole point is the broadcast, right? So this broadcast is known as layer 2 broadcast, which is represented by all F. See what you are doing actually. You want to talk to B, but you are disturbing everybody in this subnet, everybody in this room, right? By shouting, who is 1.20? Do we really need to do that, right? If I talk about layer 3 broadcast, the meaning is, I think you all know about it in your CCNA days. If you have this subnet, people say calculate the broadcast address of this subnet. And you already know that 192.168.1.0 is going to have 256 address from .0 to 255. And this last address means 192.168.1.255 is the broadcast address. Means if you send an IP packet on this broadcast address, believe me, it is going to be there with every computer. It means that what is a layer 3 broadcast address in IPv4? If you consider this subnet, then the layer 3 broadcast address is going to be 192.168.1.255. If you send this, and of course, you cannot send only IP packet over this Ethernet. You need layer 2. In layer 2, you are going to write this broadcast address. This was the whole soul theory of broadcast, right? But now, how can I send a message? See, now I am not interested in sending the message to B, right? I am interested in sending the message to this group, right? Broadcast means sending it to everybody on the LAN or maybe in a particular subnet. What is the meaning of multicast? Or sending it to other group, right? Because one group is everybody, which is a broadcast. Can I send packets to a specific group? The problem is this guy is going to have an IP address, maybe say 192.168.1.30. This guy is going to have 1.40. Can I send a packet to a specific group? not to everybody. And this approach is known as multicast. So what we do in multicast, instead of sending the packet to every host inside that group, because this host C and this host D is identified by two different IP addresses. How I'm going to deliver the same message which is coming, like this is my message, to this guy as well as this guy. Of course, I need to create two packets to send, right? But that is going to be unicast. But in IPv4, we have a technology or technique which is known as multicast, through which we can send, right? Basically, in multicast, these two computers start listening on an address, which is a multicast address. So this guy will be listening on multicast address, which is 239.1.1.1. This guy is also start listening on the multicast address, which is 239.1.1.1. If that is the case, we need to send this message to only 239.1.1.1, and it's the responsibility of the switch to send it over this interface as well as this interface and not on this interface. Why? Because this guy is not listening on 239.1.1.1, and this 239.1.1.1 is actually your multicast group address. If you do not, it is just like suppose if you listen to FM, right, you have to tune your radio to a specific frequency, maybe 98.5, right, something, and whoever is on that frequency, they can hear the song, right? So it is specifically a form of multicast, although it is not a FM broadcast, but it's multicast because it is only with that group who are listening at that particular frequency. If you see 239.1.1.1.1, it is just like that frequency, but it's an IP address, right? Why I am talking about broadcast and multicast? Because if there is no broadcast in IPv6, we are utilizing the multicast capability. Multicast is less disruptable than broadcast. Broadcast is for everybody. Multicast is for that specific group where we want to talk, right? And this is basically the comparison. No broadcast in IPv6 and how actually it works. I presume here that you all understand the meaning, how this computer number A can communicate to computer number B in IPv4 environment. Of course, address resolution protocol comes into picture, and I have explained that in many videos. This is the foundations. These are the basics, just to see this up. And I'm telling you, if you understand this process, it doesn't matter if you're learning IPv6, if you're learning VXLAN, if you're learning segment routing, right? You need to understand that packet structure. This is available in my Wireshark course. Just have a look at it. Very, very simple course, right? Now, if I talk about IPv6, so one more thing. As I discussed, the broadcast address for that network was 192.168.1.255. The corresponding broadcast address, this is L3 or layer 3 broadcast address, and corresponding layer 2 broadcast address was all F, right? This is the MAC. You all know about it. Similarly, if we have 239.1.1.1, suppose this host is listening at 239.1.1.1, so this is the layer 3 multicast address. At layer 2, we have also multicast address, which we can calculate from this address. Maybe that is x dot x dot x dot x, right? So what is happening, interestingly, that here, instead of sending the broadcast to know what is the MAC address of host B, we are sending multicast, right? But how that works? Another 5 minutes, guys, and then basically the topics are going to be very easy, right? So let's see the things in action. What exactly happens? Suppose we have this network as an IPv6 network, no IPv4. You know in IPv4 how these two host A and host B are going to communicate with each other, right? So we have an IP address 2001 colon colon 12 colon 1. Interesting IP address, right? 2001 colon colon 12 colon 1. Can you convert it into the 128-bit address? Of course you can. What do you need to do? This is 2001, right? And then this 12, you can write 0012. And then last one, you can write 0001. And whatever is the number remaining, fill it with all zeros. As simple as that. 1 octet, 2 octet, 3 octet, 4 octet, 5 octet, 6 octet. Means we have to insert those minimum, then the 7th octet, and then 8th octet. As simple as that. Double colon means insert whatever the number required after creating the IPv6 address from these three pieces, right? So I think you get the IPv6 address. Now, /64, again, this is the subnet. I will be teaching this subnetting in the real classes, right? This is just the webinar to understand the traffic flow. What is happening right here? First of all, see, the rules are same. This computer will check where it is going to talk. It is talking to 2001 : 12 : 12 2, which is this host address, host B address, host B's IPv6 address. It is going to see whether this host lies in my own network or not. This is the same check which we did in IPv4. If yes, then basically it start asking about what is the MAC address. Why? Because in case of IPv6 also, the source is going to be same, right? Source is going to be 12:1. Destination is going to be 12:2. Same thing. If we want to send this IPv6 packet into this Ethernet, we would be needing what? We would be needing source MAC and destination MAC. In IPv4, how we resolve the problem of destination MAC corresponding to this destination? We used ARP. There is no ARP here because there is no broadcast here. Instead, we use neighbor discovery here. This is going to be really, really interesting. In this neighbor discovery, believe me, guys, what happens? Right? We actually definitely know where we are talking, 12:2, right? And of course, this host knows its own IPv6 address. See the beauty of this, that how they have removed the problem of broadcast. They are saying, as soon as I get this IP address, I will start listening to an L3 IPv6 address, L3 multicast address. And suppose that is X:, X:, X. What is this? I will be talking about it. I can generate this multicast address from this number, and this is going to be interesting thing. Similarly, I will be start listening at layer 2 level also, and suppose that is Y:, Y:, Y. And these two numbers can be calculated from the single number, believe me. And if this guy can calculate these two, L3 means layer 3 address as well as layer 2 address, from the IPv6 address, I can also calculate the layer 3 multicast address and layer 2 multicast address, right? Instead of sending it to everybody, I will be sending this over this layer 3 and layer 2 multicast address. So how is the packet going to look, this neighbor discovery packet? First of all, host A will be creating this packet, neighbor discovery. And in this neighbor discovery, it is going to ask, what is the MAC address corresponding to 2001 : 12 : 1. This is generated by IPv6, right? At layer 3. So if we want to send it, we need to put source MAC and destination MAC. Oh, sorry for this. Before that, we need to put source IP and destination IP. ARP is created at layer 2, guys. Just try to understand. Here we are creating neighbor discovery at layer 3. So we need to put source IP, destination IP, and then source MAC and destination MAC. Source IP and source MAC is not a problem, right? What should be the destination MAC? Destination MAC is whatever I have calculated, Y:, Y:, Y. What is the destination IP? Whatever I have calculated, X:, X:, X, right? Because I can do this from my own IP address. I know where I'm communicating. If that is the case, really, really interesting thing happens, right? And if that is the case, this message will be reaching here and A will be replying. Believe me, I have covered whatever I should have covered in 160-minute class. I have covered in just 10 minutes. So if it doesn't make sense, if you just get only 10% of whatever I explained here, believe me, it is more than enough. But the whole sole point I would like to tell you here is that and somebody is asking how this XX and YY is calculated. Do not worry. We will be talking about it, right? So somebody is saying, please once more, don't worry. We will be covering entire thing in our live course. But still, if you need it, I will be providing you this video. And now, a little bit about offer which you are getting right now if you register for the IPv6 course. You will be getting TCP course worth of 99. And believe me, many people are passing their interviews because of this TCP, because this is one of the best thing I have created. Because most of the network engineer understand till layer 3, right? They do not know layer 4, which is TCP, and most interviews are talking this. And if you are assigned for IPv6 course, which are going to be started from 4th of June, I believe, right? And in this, there are going to be 8 classes. Very, very interesting classes. So along with this live classes, 8 live classes, you will be getting TCP course. Even in 8th class, if you say that I really do not like the course, Mr. Vishnu, what should I do? You will be getting your refund back. You will be having 8 live classes of 1 hour plus 15 to 20 minutes of your questions. We will be giving 50% discount right now. So this course cost is 2,500, right? And if you do it right now, it is going to be 1299. Maybe after 10 minutes, if you do that, means after 10 minutes of this. Then basically what you are learning, you are going to build AI ready networking, right? You are going to build the highway for AI to run on. So this is going to be the future technology. So overall means this is no brainer to join this course right now because you are getting the TCP course free. And if you do not like in the 8th class also, you just need to say, and your money is going to be returned. It is just 1200 means approximately 12 to $15 course, as simple as that, right? I just took this opportunity to explain my this thing, right? The course. I think we have already gone through plug and play nature of IPv6. Now the interesting thing, where exactly is IPv5? Believe me, guys, IPv5 was developed around 1980s, right? But that is specifically for multimedia services. For example, how we can give, if I want to run a movie on everybody's everybody's laptop, how I can do that? This is multimedia streaming. The protocol was known as Internet Stream Protocol, ST, right? But that didn't kick off. Means that was a failed project, but still IPv6 guys thought that although it was a failed project, but IPv5 was there. So let's leave it there. We are going to build IPv6. So there is a history behind it. IPv5 is for stream protocol, right? Which was for multimedia streaming. So that's what I wanted to cover. And then last, but not last, this is one of the diagram which I got from Google, right? And you can just go into this website to understand what is going on. This is one of the most interesting fact. Right now, as I mentioned, in 2011, the IPv6 adoption was only 0.6%. But you still remember in 2011, IANA said, I do not have any IPv4 addresses, just work on IPv6, right? In 2025, the Google says the number of people who are on IPv6 is 49%. Believe me, guys, 49% of people, the traffic of internet is on IPv6. And within no time, it is going to be 100%. Why don't you learn that, right? If we talk about France, the adoption rate here is 85%. I think the highest. If we talk about India, guys, it is 75%, way better than many countries. If you see this dark color, right? India is 75%. Australia, 34%. If we talk about Reliance Jio, almost 95% of its mobile user get IPv6 address, 95%, right? Really, really interesting, really interesting. Now, last but not the least, AI and IPv6. So many people were asking about this, that why you are including AI here. You all know that in the upcoming world, AI is all there, everywhere, right? If you talk about autonomous cars, AI is going to be there, where these autonomous car wants to talk to each other. If we talk about AI, AI needs data. And to move this data, we need networking infrastructure. It is going to be huge data. It is going to be huge number of servers. You must have seen that Dubai, in collaboration with various nations, is creating this data center. It's going to be biggest AI data center. Such data centers are going to be everywhere in this world. If that is the case, we need addresses for them too. We need peer-to-peer communication. If that is the case, we need to build IPv6 infrastructure. Who is going to build this IPv6 infrastructure for AI? We guys, we are going to build this, right? And we can build it if we understand this IPv6. Now, one by one, raise your hand. You can ask as many questions as you like. Anybody, any question? No, not on chats. Okay, I can take the questions in chats. You can unmute yourself. Okay, so the first question I got from Sachin is, how is it getting assigned with IP address without DSCP? Will it not conflict? And this is one of the most interesting things which we will be covering, guys. Do not worry about it, right? So, so what happens? Suppose we have a router here. and we have a switch. I'm talking about IPv6 network, right? And we have this host. The question is how basically this guy is going to get the IPv6 address without DSCP, and whether it is conflict or where there is a conflict or not, right? So on this router, definitely I need to configure the IPv6 address and the subnet. And this is the beauty of IPv6, that it is going to advertise some messages, which is known as neighbor discovery messages through neighbor discovery protocol, which is part of ICMP version 6. Believe me, we have ICMP. We all know ping, where it's a part of ICMP. This is the version 4, and they have improved this ICMP so much it has become ICMP version 6. And lots and one specific thing is no broadcast, right? So if we talk about here, right, when this router advertise this, it will be reaching to all the hosts, right, which are listening to a specific multicast address. So all the hosts in IPv6 are going to be listening to a multicast address. This neighbor discovery message will be reaching here. From this, it is going to calculate the starting 64-bit, whatever the IP subnet you have configured. So 64 bits are done. Last 64 bits are calculated using an algorithm used as EUI. We will be talking about it. And believe me, this is going to be different. It is based on your MAC address, and MAC address is unique, right? And you must be thinking, Mr. Vishnu, MAC address is only 48-bit. How you are going to calculate 64-bit? This is how EUI algorithm work. Very, very interesting thing. Believe me, your mind is going to be blown. We will be talking about this addressing, I think, in second class of our live course, right? But believe me, one of the most promising feature of IPv6 is its automatic configuration, which is required. For example, if we have thousands of devices, thousands of AI autonomous cars are riding, we need that capability to configure the IP address as quickly as possible, right? Thousands of IoT devices, lakhs of IoT devices are coming. We need this auto configuration. Now let's see the other addresses. Somebody asked that how this x.x.x.x, which is the multicast address, multicast IPv6 address at layer 3 is calculated. We will be talking about it. Again, it is very, very simple. Again, it is going to be 128 bit. Starting some bits are already fixed to do that. And last 24 bits we are going to create from the IPv4 address. Similarly, once we have layer 3 multicast address, we can have layer 2 multicast address calculated from layer 3. This is also explained. This is also we have done in IPv4. If we talk about can we get class repeated if not understand, class is going to be recorded. Try to understand as many times as you want. But if you are in the live class, your questions will be answered, whatever you say. I understand that in today's 10 minutes means if you do not get this multicast address and so on, do not worry about it. I will be talking about it. Guys, you can talk also. You can just unmute and talk. So the question here is, what is the smallest subnet we can create in IPv6? We will be talking about it. I haven't discussed subnetting. So if I talk about it now, it is not going to make sense for people. Can we get, I think we will get recorded video. I think you have already mentioned. Can you explain what topics will be covered in each session? If you can share the document in WhatsApp group, it will be helpful. Definitely. Even what I can do is I can showcase you right now. So what you need to do is you just need to go on my website, right? The website is simple, www.bridgewhy.com, right? So if you see here courses, the first thing you are going to get this IPv6 from scratch. This is the course actually, right? You go to that, and right now, although the price is showcasing a buy now for 2499, believe me, just within just 15-20 minutes, for all of you guys, it is going to showcase you a 50% discount here. You click on this and you will be getting the discount. You do not know buy now because as I already promised that it is going to be half of the price if you do it. So about the package, what basically you are going to learn, everything is mentioned here. Why behind IPv6, IPv6 addressing, subnetting from scratch, packet format is extension, neighbor discovery protocol, duplicate address detection, static and dynamic routing basics of OSPv3 with BGP, IPv6 transition technique, because people have hard time to understand that implementing IPv6 is way easier than IPv4, but still people are not implementing it because they do not understand the transition techniques. Means you can have your IPv4 network, you can have your IPv6 network. It is known as dual stack, which we are going to talk about. Yes, there is a need of net64 as a transition technique. We will be talking about that too. Myths, eye-opening real-world fact, hands-on with Wireshark and EvenG. This is going to be the course content. So I think everybody's, but I request you do not Do not do it right now because it is not showing the discount. I'm not sure, but within 10 to 15 minutes, I will personally check it. If you want, you can do it later. Nowadays, most of the application have flexibility dual mode. That time, which one IPv4 and IP? This is one of the most interesting application. Do not worry about it. We will be talking this in our live classes. That on what basis these guys select whether it's an IPv4 or IPv6 address should be chosen, right? So we will be talking about it. Mr. Ravi, please go ahead and ask your question.
Yeah. Let's say I have an enterprise network. So can I use both? Is there any use case IPv4 and V6 together?
Right now, everybody, even the biggest service provider, as I mentioned, Geo is already on IPv6, right? So right now, and it doesn't mean that I cannot access Geo using my IPv4. So there is a transition technology known as dual stack. Most of the enterprises who have converted themselves into IPv6, they have this thing which is known as dual stack. The meaning is they are on IPv4 as well and IPv6. Both protocols work simultaneously together. Even this is the transition thing or the migration thing. You need to configure first IPv6 just on the same router, same switches, right? Where you have configured IPv4 and the migration approach is then once your IPv6 network is up and running, just remove the IPv4. But if you would like to have IPv4 and IPv6 together, almost every enterprise right now is using this model that they are on IPv4 as well as IPv6. The model is known as dual stack. We will be covering it. Okay. Anybody else?
Thank you.
Just unmute yourself and ask your question. Okay, somebody is saying, let me again some questions. Somebody is asking. I have already enrolled in the live class. Do we have any separate WhatsApp group? Yeah. So for the live classes, we will be making a separate group. There are already 70 people who have already registered on for the live course, right? Means you can also do that, but wait for the 50% discount. I will be informing you on the WhatsApp group that now 50% discount is there. So you just need to go onto the website www.bridgewhy.com, right? Courses IPv6, and you should be seeing the discount here. Once you click on buy now, you will be seeing the discount on checkout, the 50% discount. Anybody else? I think we are good. There is no question. No more question. Okay.
So Vishnu, one last thing.
Mm-hmm.
Just maybe a little outside.
Mm-hmm.
So let's say I started learning IPv6,
Mm-hmm.
and how short or how long I will start deploying IPv6 network. For example, I can get the project for the IPv6 deployment.
So if you start learning it now, see whatever you know from IPv4, right? This
Mm-hmm.
is going to be crucial because most of the things like before sending to the packet, we need to check whether this is on our subnet or not. The subnetting thing, it is going to be same, right? In IPv6 also. But there are new ways like neighbor discovery, right? Where you need to implement, where you need to put your mind. So if you do these 8 classes, so although IPv6 say is a journey of 100 kilometer, but believe me, as I mentioned, I always mention that engineers just need a start. So you can walk with me in those 8 classes, 20 to 25 kilometers journey, and so that you can do any project on your own. So once you understand, once the foundations are strong in IPv6, right? Any project comes to you, definitely there are going to be requirement of dual stack or maybe something else which you configuring OSPF, configuring BGP, which you can definitely do after this course. But if they want to add something on top of it because your foundations are going to be so strong, definitely you can read the articles, you can read the documents, and if you read the documents after these 8 classes, those are going to be very simple looking documents for you. It is going to be easy to understand because your foundations are strong. This is not with respect to only IPv6. I tell this if you want to learn even BGP to begin with, right? Start building foundation. Have your foundation strong for starting 20 kilometers, right? If you have this, any project come with any requirement with the BGP, you can do it by reading the document because you have a strong foundation. This is how I would like to go with any specific technology. So if you say after these 8 classes, if your manager says, would you like to work on IPv6 project? I think you should raise your hand. Am I able to answer your question, Ravi?
Yes, thank you.
Perfect.
Absolutely.
So thread network, openthread.io uses IPv6. Can you cover how thread network IPv6 assignment is different from outer assigning IPv6? Pawan, I really do not have any idea about what you just asked, but definitely I would like to read about it. that how IPv6 assignment is different from assigning means what is your whatever question. Please give me some time, but it is interesting to think. Okay, anybody else? Guys, again I'm saying,
Vishnu sir, one request.
please go ahead, Ujjwal.
So like, yeah, so sir, actually, the point is that definitely it's really thanks to you. Like, I will join personally to that IPv6 course. But thing is that I already subscribed your last 1 year access actually. But point is that I cannot continue because of current project pressure and something. So any planning in the future? You are starting from the scratch again the live class.
For
Actually,
IPv6.
personally,
For IPv6.
Not I enter like from the scratch to the IPv6.
Yeah,
I mean
the problem is, see, okay, I answer. This is a really good question, but what we do, Ujjwal, I understand your question. Just few more minutes if you want to understand this. What I am building. See, right now, if you see that on my website there are 25 courses. Everything is taught live to live audience. Sometime more than 50, sometime more than 100 people sit in those classes, right? But if I talk about that, how I created these 25 courses in last 2 years, because I haven't repeated them. If I repeat them, then I am not able to create, right? If you consider what courses I am going to create next, segment routing is there, right? Then AI for network engineer is there. This is going to be phenomenal course of 3 months, right? Where we will be learning how basically AI works, not to write the prompt, how to write the good prompt to get something from AI, how exactly AI works. And if I consider this, believe me, there are more than 100 courses which I envision, which are in my list over the period of 6-7 years, over the period of 4-5 years. So, but if I repeat the existing course, I won't be able to create them. But believe me, if I have taught SD-WAN, I have done so much of effort in creating SD-WAN that if I would like to teach them once again, it is going to be of same quality. Everything is going to be same, right? Because I have put my effort in, a lot of effort in there. So if you have these videos, you have already subscribed to 1 year subscription, right? 1 year subscription doesn't come with live classes. So even IPv6 course, when it's finished after 1 month, when we finish this course after 15 days or 1 month, this will be added to your 1 year subscription. The whole sole point is, at any point, if you start, for example, if you want to learn VXLAN from scratch, just start those videos, and believe me, 100 people are sitting with you, because the USP or the best thing about these courses are that people ask question every half an hour. People ask questions. So whatever is coming to your mind definitely would have come to those 100 people mind. Just start any course, you would love it. So the overall is, in coming future, definitely I'm not going to repeat whatever I have taught, right? Except for few technologies like SD-WAN, because it has changed a little bit in names and all. But I'm not going to repeat OSPF BGP once again, or the switching or multicast VXLAN once again, because it is right there in one of its best form. Okay, Ujjwal?
Yeah, sir. Thank you.
Yeah. Anybody else? Any doubt? Means anything, means with respect to this webinar, anything which is coming to your mind, some suggestions or whatever, means if there is a fear with respect to AI, anything you can ask, guys. I am here. Hindi में पूछो, English में पूछो, no problem. Yeah, Vijay, go ahead.
Times when the session is going to start?
These will be started from 4th of June, means Wednesday, right? There are only 3 classes per week, 3 classes 1 hour, and these are going to be Monday, Wednesday, and Thursday. We choose Thursday after Wednesday because Friday, very less people join the class, and for the obvious reason. Okay, so only 3 classes means 8 classes. So it is going to take 2.5 weeks to complete this course. We will be starting for 4th of June. I think from 20th of June it will be completed, 20th or 22. I think Mamta has a question. Mamta, please go ahead.
Yeah, Vishnu.
Yeah, sorry, Mamta. Mamta, I'll come to you. Thank you. You are most welcome. Sure. I'll come to you. Yeah, Vijay, complete your question. So sorry for this.
Yeah, sorry. Timings.
Yeah, timings are. And by the way, this course is going to be in Hindi as well as English. Hindi timings are 7:30 to 9, and English timing are 9 to 10:30 p.m. IST. Okay.
Thank you.
Yeah, Mamta, please go ahead.
Yeah, first of all, thanks Vishnu for creating such an very simple and easy to understand kind of all topics. And my question is basically not related to this topic. So I day in and day out work with the TAC engineers, and I'm basically not a non-technical, but yes, I can understand technical as well. And I always join your webinar because you start from the scratch, which makes me, feel very comfortable and confident saying, okay, I can also learn.
Yeah.
So adding to that, what I wanted to understand is, I can see so many topics in your list. As a fresher, how can I start, and from which topic I can start to get some kind of, a deep knowledge into this technical stuff?
Yeah.
So any guidance on
Yeah,
that?
definitely. And I have created a video on that also. So if you go to the plans, right?
Okay.
And if you go to down here, I have created a specific video in what orders you should be going to get this. If you are absolutely new, right? It is just a 5-minute video. For example, you should be starting from CCN or BJob ready if you understand Hindi, then switching fundamentals, then routing fundamentals. If you really want to understand a little bit routing, OSPF, then basically you talk about TCP, then BGP, MPLS, everything is there in this video. Okay.
Oh, okay.
I think this was your question, right?
Yeah, this is what I was looking for. Thank you so much. So
no worries.
You have quick link here. I can refer quickly.
Yeah. So let me type it here. Chat.
Yeah.
And yeah. So I have pasted here. My website name is www.bridgewhy.com for everybody. Means if they. So I am pasting this course link also, right? In case anybody of you is interested. But just wait for 10 minutes before. Means I will be opening the discount pretty soon, and I will be letting you know over the WhatsApp.
Okay.
Anybody else? Anyone? And sorry to destroy your Sunday morning, but I think learning should be continue. We should continue learning because people have a lot of what we can say anxiety or about their future, that what is going to happen. Only one thing if you do, maybe in 1 week, if you just spend 2 hours learning new things or anything which you do not know, it is going to make you more relevant in upcoming future. Having said that, I am seeing price in dollars. Can I pay with INR? Believe me, the prices are almost the same. I will be reducing for dollars also. You will be getting 50% in. So prices are going to be same, Mr. Khan. So having said that, I don't think there is any new question. I don't see any raised hands also, right? Thank you so much for being a wonderful audience, and see you pretty soon in the live classes. Bye for now. Just wait for, and thank you so much for these lovely emojis. Thank you so much for clapping. See you in live class. Bye for now.